good morning. Hello and good morning to everyone. So our today's loot code question is 1536, that is minimum swaps to arrange a binary grid. So in this question we are given a n cross n binary grid, and in one step we can choose two adjacent rows and swap them, and a grid is said to be valid if all the cells above the main diagonal, if all the cells above the main diagonal are zeros, right? So we have to return the minimum number of steps that we need to make the grid valid, and if it is not possible then we have to write return -1, that the grid is not valid. And in this line it is explained what is main diagonal. So let's see some examples. So in example 1, this is our initial matrix, right? And what we have to do is we have to make it somewhat like this. Like these two elements should be 0 and this should also be 0, like all the elements above this diagonal should be 0. So what we do is, like we want two zeros here, so we want this row to go to this place, right? So what we do is, first we swap these two places, and then this row will go here, and then we swap these places, so we get these two row here. So initially, to take this row to this position we needed two swaps. Now after this first row will come here, and this this row will come here, then again we will be swapping both these rows, right? So total number of swaps will be 3. Let's see the next example. So in example 2, this is our grid, and we have to tell whether, like, how many swaps we need. So here what, how many in the first row, here we need three zeros, three trailing zeros in a row. So do we have any row in which we have three trailing zero? No, none of the rows has three trailing zeros. Trailing means zeros in the last. So none of the rows has three trailing zeros, so it is not possible to make this grid as valid, so we return -1 directly. Let's see the next example. So in the next example, the grid is already valid. So if you notice, here we have 0 0, here we also have 0, so all the elements above the main diagonal are zeros, so it is valid only. So the number of swaps required is 0 only, right? Then let's look out the constraints. So constraints is the number of rows and number of columns can be up to 200. So what are the possible complexities we can use? We can use big of n square, n log n, and big of n or log n. Like these are the operations that we can use, and grid of I or j is either 0 or 1. So let's see the approach. So what do we want? Suppose we are at this row, so how many trailing zeros we want? We want, for this row we want three trailing zeros. For this row we want two trailing zeros. Like this is zeroth row, this is first row, this for second row we want one trailing zero. For third row we want zero trailing zeros, right? At least zero. So if you'll see here, this is the ith row, and n is equal to 4. So for ith row, how many trailing zeros at least we want? So we want n minus I minus 1 trailing zeros at least, right? I hope you get this. See, this is a zeroth row, and for zeroth row, how many trailing zeros we want? So that is n is the size, that is 4, minus I through n is 0, minus 1, any 3 zeros we want. For row number 1, we want 4 minus 1 minus 1, 2 zeros we want, right? So what we do is, uh, we now know that for each row how many zeros we want. So for at row index I, we want n minus I minus 1 trailing zeros. So what we do is, we will convert this whole grid into an array, where this index store how many trailing zeros first row will have. Then this index like 0 1 2 3, where trail this tz of r, for each row r we will be storing how many number of consecutive zeros from the end of the row or the trailing zero. Suppose our row is 10100, so here see two trailing zeros are there, so tz of this row will be 2. So for each row we will be storing how many trailing zeros does it has, right? So after this, now our problem becomes like we have changed the problem from grid to a single array, right? So what we have to do is we have to reorder the rows using adjacent swaps, so that for every position I, tz of row at I should be greater than or equal to n minus 1 minus I. That is, for every row I, the number of trailing zeros should be greater than or equal to n minus 1 minus I, and with the minimum adjacent swaps. So once we store all the trailing zeros of all the rows, what we'll do is we will greedily select the desired row, right? So let's see an example. Because this one is not possible, we will be taking the first example, that this one. So if we'll make the trailing zeros array here from this matrix, so we will be getting, so first row has 0 trailing zeros, so it will be 0 over here. Then it has 1 trailing zeros, then this way has 2 trailing zeros, right? And then what we do is now we have to we get a trailing zero array, right? So now what we do is we will use a loop from I to n, and for I is equal to 0, how many trailing zeros we want? N minus I minus 1. So n is 3, 3 minus 0 minus 1, we want two trailing zeros. So what we do is we will iterate over this trailing zero array and find which is the first row where we are getting at least two zeros. So we'll see, here we are getting one, here we are getting two, so here we are getting two trailing zeros. So what we do is we now have to bring this row here. So how many swaps are required? So the swaps required are j minus I. I is the this index and j is the index where we have find this trailing zeros. And suppose if we won't find 2 at any place, in that case we will be returning minus 1. That means it is not possible. So once we get this 2's, what we do is we swap the adjacent ones. So after this step, our trailing zero array will become like this. So 1 will be here, then 2 will come here, then we again swap 2 and 0, so 2 and 0. Now if you see at index 0, we at least require, with the number of trailing zeros that we require is greater than or equal to 2, so we get 2. Now we move to the next index. So now here we have 0, but how many we required? N minus I minus 1, that is 4 minus 1 minus 1, yani wait, sorry, 3, n is 3, so 3 we require one trailing zeros. So again we find in the array after this ith index how many, like which index has this number of trailing zero. So this index has number of trailing zeros, so we again swap this one. So after this, what our trailing array will look like? It will look like 2 1 and 0, right? Then we move to the next index. Here we only require how many trailing zeros? Greater than or equal to 0, but it already has 0, so we won't be doing anything, right? So after this step we will return the number of swaps. So I hope you explained, you get this approach. So let's see the complexity of this approach. So row for each row we are checking all the value of trailing zeros of the future rows. So the time complexity is big of n square and the space complexity is big of n, as we are using another array, right? So let's see the code of this approach. So what we do is, first of all we will compute trailing zeros for each row, like how many zeros each row have in the end, that will compute, right? And that we will store in the array called trailing zeros, right? So what we are doing, we are going to each row and then iterating from the last, and then we'll keep counting until we'll get 0. And once we get a non-zero element, we break the loop, right? So see, if you have seen here, we have put two condition. One is either j should be greater than equal to 0, j is column number, and grid of I comma j is equal to 0. These are the two conditions we are checking every time we are coming inside this loop, right? And once our loop got broken, we'll push the count of trailing zeros in the array. Now next what we do is, initially the value of swaps that we require is 0. Then what we do is, for each row I, what is the need is n minus I minus 1 that we have discussed above, right? So what we do is, we'll now try to find the first row j which is greater than I, such that it has enough trailing zeros. Like, enough trailing zeros means no, it should be greater than or equal to needed, right? So what we do is, we'll uh, taken j is equal to I, and then we check, while j is less than n and trailing j is less than needed, we skip all these parts, right? If trailing zeros is less than needed, that we won't take, so we increase our j pointer. And once we get, if j is equal to n, that means we have reached to the end of the array, but we haven't get a single element which satisfies our condition, so we return -1, because in that case the answer is not possible, means there is no row that has the required number of trailing zeros. But what if we get some element? Suppose we get some element at index j, and right now we are at index I. Then the number of swaps that are j minus I, because we have to swap adjacent rows only, right? So we will increment swaps by j minus I, and after that what we do is, suppose this is our array and this is I, this is j. Then we swap the adjacent element. That, like, swap first these two, then these two, and then these two. Like, then this j will come over here and this I will come over here. So after this, after incrementing the swap, we'll swap all the adjacent rows, right? And at the end we'll be returning the total number of swaps. So I hope I am able to explain you this whole approach properly. So if you get the solution, please make sure to like, share and subscribe. Thank you.